so scary. Sorry, that is not necessary. So we said here for our sequence, whatever we read here, right? Our sequence is obviously going to have to start with like 0.8 because the first day they're going to like travel 0.8 kilometers. The next day, because they are going to add another 0.8, it means that they will travel like 1.6, you see? Because it's almost like if you have a fence that goes this far, right? So this, today you walked 0.8, right? Tomorrow you're gonna add another 0.8. It means that you walked 1.6. And then the next day you're gonna add a 0.8. It means that here you walked 2.4, going onwards. Do you see?
Yes.
Yeah. So that's the idea behind the sequence that we are working with here, right? It's just going to keep going like this. So the next one here is going to be 2.4. The next one from there is going to be 3.2, going on and on and on. You see it?
Mm-hmm.
Perfect. So with all this being said, right, we have to be careful now. Like all this being said, we have to be careful because now the issue now is this has to go all the way to like 40 days. So somewhere here there's T40 and we don't know what that is, you see, but it almost doesn't matter now because the question is saying they then return back to the entrance to lock up their tools in the shed at the end of each day. It takes 40 days to put up the fence. How far would the workers have traveled in total? So putting up the fence, oh yeah, it looks like the T40 is all we need to find because day one, they walked this much. Day two, they walked this much. Day three, they walked this much. Day four, they walked this much. Day four, they're going to walk a certain amount of kilometers. And then the question is asking how far would the workers have traveled in total? Sure. Yeah. So them asking us how far they would have traveled in total, they technically want us to then go ahead and add this and this and this and this. Do you see that?
No.
You see it, right?
But I know this is a bit too off, but then you see, since they're going to build their fence, right? From the entrance, they build their fence 0.8 kilometers far, and then they have to go back that same day. Doesn't that mean
Yeah.
that the first day it was 1.6, and then the next day they carry on from where they were, the 1.6?
Yeah. I actually get that logic as well. Because the strange thing is, I was also thinking that myself. So I think if we're both thinking it, we might as well go for that idea. Because, yeah, it is what it is. Might as well go for that route. Because, as you said, if the first day they put up 1.8, I mean 0.8, they're going to go wherever they have to go and then come back. So the total distance is 1.6. The next day, they're going to put 1.8 again. So meaning they walk 1.6 and walk 1.6 back. So that's a total of 3.2. The next day, they put 0.8 again, meaning they walk they walk here, how much now? Like 2.4 and then 2.4 back. That's going to be like 4.8, going on and on and on. So our sequence will actually have, let's see here, our sequence will actually have these numbers here, 1.6, 3.2, 4.8, going on and on and on. Now, with this kind of a sequence, we have to check what kind of a sequence we have here. 3.2 minus this is just 1.6. This minus 3.2, it looks like it's also another 1.6. Is it? I think.
Wait, you got 3.2?
I don't know. Yes.
Because I got 1.6, then the next one 4.8, and then the next one 11.2.
Okay, wait, hold on. So we said on the first day, right? They put up 0.8 of fence.
Yes, 0.8.
Yeah.
But then
So
they
when
went back. Yeah.
yeah, so they put up 0.8, and then when they went back, it means they would have traveled 0.8 times 2, right?
Yes.
which is 1.6.
Yes, 1.6.
Cool. So
Then
that's why
the,
we put 1.6 here. Do you see?
yes. Then the next day,
Then the next day they will put up another 0.8, meaning they walked 1.6 going, and then they walked 1.6 going back.
wait, but
Yeah, because look, on the second day they put another 0.8, right? Meaning while they were going where they were going, they walked 1.6. And then when they were coming back, they walked another 1.6, which is a total of 3.2.
but then isn't it when the okay the second day they already have the 1.6 and they build their fence then 0.8 and then they have to go back again from the 0.8, so it's another 0.8 plus 1.6 again.
Oh, you're talking about the total distances now. You're trying to accumulate the distances as you're working. Well, okay, yeah. So remember, with what we're doing here, we cannot, if you can imagine, for 40 days, we cannot already be adding up all the days while like still calculating what we're doing. Because what we're doing here, all we're doing now is we're just trying to keep a record of how many kilometers we walked in each day individually before we can even worry about adding them all up together. You see, because this is more like saying day one, they walked this much, day two, they walked this much, day three, they walked this much. So that at the end, we just add up all of them to see how many kilometers is it for those 40 days. You get?
Oh, okay.
Yeah, of which to do that, we need a formula, of which my only question now is, has that formula been taught? But since we're doing what we're doing, I mean, like, let's see here, our common difference, we can see here, it is definitely 1.6, you see. So in our sequence here, we already know that A, which is the first term, or let me put this, any arithmetic sequence, right, has a general term that's in this format, A plus n minus 1d. You see, I don't know if you bumped into something like this within the playlist.
Yes, I did.
Yeah, and if you can recall, A specifically means first term.
The first term is
Yeah, and then D means common difference.
difference. Yes.
And then what you may call what's next now? Yeah, so from here, so all you need to know here is this is just a general term, right? General term. It doesn't really help much for our question. What you actually need to keep in mind for our question is the sum of formula. Because here when they're speaking of the total days traveled, we need to sum up all these. So your sum formula for an arithmetic sequence, let's say here sum of formula. Your sum of formula for arithmetic sequence for a sum of formula, let's just say sum formula, because when we say sum of formula, it just sounds a bit weird. Let's say sum formula for arithmetic pattern, for arithmetic number pattern. The sum formula for arithmetic number pattern is like this. And this is something you can just remember, because the way this question is set up, it looks like we have to know this formula. But then even we'll do what we'll do now, and then we'll actually have to check the memo for this question and see what has been done so that we don't do things that are above our pay grade, you know? So yeah, A is the common difference. A is the first term. The one thing we forgot here was N. N is just the position of like a specific term. But then for your sum formula, A is still the first term. Let's put your first term. D is still the common difference. But then let me see here, difference. but then n is the number of terms being added up.
Oh, okay.
Yeah. Yeah. Let's just say number of terms added. So for this formula, already in our question, right, we already know that the number of terms being added is just 40. Our first term is 1.6. Our common difference is just 1.6, you see. And then we can just put all that in our formula. So we're going to have here S40, the sum of the first 40 terms, just 40 over 2. And then here you have bracket 2 times 1.6. N is going to be like 40. And then D is going to be what? D is going to be the common difference, which is just 1.6. And then all this, we just have to put in the calculator.
The answer is 1,312.
1,312.
Yes.
Cool. So, let's see. What I need to see. Yeah, so if that's the answer, then that's it. All we need to do now, let's double check with this memo and see what we can get. This is Bridge House 2016. Let's see the memo here. Bridge House 2016, question number. Yo, I hope this thing doesn't do its funny business again. Ah, dang it. Like, please, no. Ah, man, I don't know this thing. Let me try it on the laptop. Hold on. Let me then stop this. I need to stop this recording. I'll just pause it. Let me see. Let me just pause it for now. Whoa. So yes, our answer is definitely correct, as we said. So the formula that the memo used is this one.
Wait, were you about to record?
Pardon?
Were you about to record? That's why you went to Volvo.
No, I'd forgotten to press play because I'd paused when we were like checking the answer. But then the thing is, I'm saying the formula that they used is another SN formula if you have the last term. You see, so the formula that they used here is there is N over 2 and then A plus L. You see, where L is the last term. You see, so meaning if you wanted to use this formula instead of this one up here, if you wanted to use this formula, right, all you'd have to do is in your sequence, you have to work out what is T40. You see, in your sequence here, you would need to work out what is T40 using your general term. So meaning in your general term, you know that Tn is equal to A plus N minus 1D. So here you'd have worked out T40 first, and then you'd have gotten like, let's see what you'd have gotten here. T40, T40 is like 1.6, and then 39 there, and then like 1.6. So that's like 64. So T40 here would have been like 64, right? And then as long as you have the last term, now you can use this formula. The sum of the first 40 terms is just 40 over 2, 1.6 plus 64. And then you'd still have gotten the 1312. So yeah, mentioning this really helped because Mina, I was like, oh, do they really want us to do that? And then, so yeah, I'm glad that you really mentioned it. So thank you so much. Thank you so much. You saved the life, man. You saved the life. So you should be happy. Cool.
No, I was Googling. Oh, okay, cool.
I think let's make this one the last question before your brain pops, because I think we've been here for, I don't know, a long time. It says, how far do the workers travel on the 30th day? So we just have to get T30 from our, what you call, from our general term. It's T30, let's see. T30, we're just gonna put 30 over here, where n is. So it's gonna be like 1.6, 30 minus 1, D. And then, we have our what?
48.
Pardon?
48.
48. Yes. That's what that memo said also. Yeah. So yeah. So it looks like this St. website is really doing the jazz, because it gave us what we are needed. Yeah. So
Yes.
it's good. Anyways.